Yeah, good afternoon. So once again, we will meet for this your last semester. So I will be dealing with the subject that is advanced concrete technology. So earlier I have taught to you design of steel structure in the third year. So I will continue this subject for your final semester. So actually this is the elective subject, elective number 4, professional elective course 4, and the name of this subject is advanced concrete technology. So earlier you have studied the concrete technology in the second year engineering. So this subject is the advance, as in this concrete technology subject. So some of the advances we have to learn related to concrete technology. So we will see one by one syllabus, then you will get what included in this particular subject. So before going to syllabus, see the syllabus, we will see the here teaching scheme. If you see here, the teaching scheme is having a 4 lecture per week to us and practical 2 hours per week. So, and then examination scheme for the subject is 30 marks ISC will be there, 70 marks end semester examination will be there, and oral will be there. For this subject, oral examination is there, and ICA term work will be for 25 marks. So in semester examination 30 marks, end semester examination 70 marks, then oral examination 25 marks, and internal assessment, continuous assessment, that is term work for 25 marks. So keep in mind, for these subjects oral examination is there for 25 marks based on the experiment. Okay, so now why we have to learn this subject, this advanced concrete technology? What are the outcomes of this subject or outcomes of this course? So outcomes of this course are, the first outcome of this course is select proper admixture to obtain concrete of desired properties. The first outcome of this subject is proper admixture. We have to select the proper admixture to obtain the concrete of the desired properties. See, you have learned the various grades of concrete: M10 concrete, M15, M20, M25, M30. Likewise, you have seen. But when we will go more M25, then we have to use mixed design, and if we use the mixed design for the making concrete, at that time we have to use the admixtures to obtain the strength of concrete. So the select proper admixture. So why we have to admixtures? We have to add the admixtures because sometimes we have to maintain the workability of concrete. Sometimes we have to achieve the early strength of concrete. Sometimes we have to place the concrete on site after making the concrete 1 or 2 hours. RMC मधून ज्यावेळी concrete site वरती येतं त्यावेळी many much spam is required from RMC plant to the site. So this time period is more time period. So maintain the workability quality of concrete, we have to use the admixtures. So what proper admixtures we have to use, that that we have to select. So that is the one of the outcome. It means we will know what types of admixtures are there, and that we have to add in the concrete while making the concrete. That you will learn after the end of this subject. If you learn this subject, so at the end of this subject you will get this first outcome. Second outcome is related to adapt appropriate types of special concrete for desired results. So types of special concrete. So there are so the concrete means, we know the addition of cement, sand, aggregate. Correct? So this is we know. Concrete is nothing but addition of cement, sand, aggregate. That's it. But there are various special types of concretes are there, which are having good strength, which are lightweight concrete, which are high performance concrete, which are high strength concrete. So many types of special concretes are there. That unit number 4 is there. So that appropriate type of concrete we have to select in this particular second type of the this will be second outcome of this subject. It means you are doing the concrete in the seawater. You are doing concrete in seawater, or you have to get early strength of the concrete. So at that time, some various types of special concretes we have used, and that appropriate selection of the type of special concrete is the also the outcome of this particular subject. Then third outcome of this subject is a design a concrete mix required strength and workability properties. As I told, so there are various grades of concrete M10, 15, 20, 25. If M10 concrete is there, so what is proportion of M10 concrete? M15 concrete is there. What is proportion of M15? M20 is there. Who will tell? So these are the grades of concrete. So there are proportions are there. So for M10 concrete, 1:3:6 proportion is there. For M15 concrete, 1:2:4 proportion is there. For M20 concrete, 1:1.5:3 proportion is there. So likewise, for M25, so proportion is 1:1:2 is there. So up to this 4 grade, we can use this proportion. But more than M25, if we go for the higher grade of concrete, M30, M35, M40, M50, M80, M90. So if we go for more than M25 grade concrete, then we have to use mixed design, and we have to go for the mixed design. So the third outcome is a design concrete mix. It means how much proportion of cement, how much proportion of sand or crushed sand, or how much proportion of aggregate that we have to take on the basis of design mix. So for that, some parameters are required. Properties of the cements are required. Properties of the aggregates are required. Properties of the sands are required. To that properties, it means water absorption. How much water absorption of the aggregate? How much water absorption of sand? So after these 4 grades, if we go for next grade, we have to concrete mix, do the concrete mix design. So in the unit number 7, we have to do the concrete mix design, and you will, if you attend the theory examination, then there may be a 8 to 10 mark question will be there on the concrete mix design. It means we have to solve the design the mix concrete. So you have to solve the problem. So problem will be asked on this concrete mix design. So how much proportion of cement, how much proportion of sand, how much proportion of aggregate we have to use for the grade for M30 grade, M40 grade, depends upon the some properties or parameters we have to study. So this is the third outcome you will get from the particular subject. Then fourth is the adopt appropriate method for repairs and maintenance of concrete structure. So fourth outcome of this particular subject is to adopt appropriate method for repair and maintenance of concrete structure. So which methods we have to adopt? Which methods we have to adopt for the repair and maintenance or repair and rehabilitation of the subject? Sorry for disturbance. So appropriate method for repairs and rehabilitation. So see, the concrete structures, you have seen so many concrete structures. Have you seen? If we go outside of our room, or we whatever in the room we seated, that room is itself of concrete structure. Or if not, then if we go outside our room, so you can see so many concrete structures. Start from building to the water tank, then dam, bridges, apartments, so many structures you can see of concrete structure. But so after so many years, it will be the deteriorate. Are you getting? So after 20 years, after 25 years, after 30 years, after 35 years, it will be the deteriorate. It means their cracks will be developed in the concrete. The steel will be corrugated. So some deterioration will be takes place. So if such deteriorations are takes place, then we have to go for some repairs and rehabilitation. Some repairs we have to do. So the such repairs and rehabilitations we have to do. We will know how to do the repairs and rehabilitation in this particular subject. So unit number 9 is based on the repairs and rehabilitation. Okay. So so these are the outcomes which we will gain after the end of this course. Okay, you can see the syllabus of this particular subject. So section 1, unit number 1 is related to the review of cements, including blended cements, chemical and physical process of hydration, aggregate, coarse aggregate, natural sand, and crushed sand. So what are the ingredients of the concrete? So the ingredients of concretes are cement, sand. The sand may be natural sand or artificial sand, or we can call it as a crushed sand or aggregates. So these are the basic ingredients of our concrete. So unit number 1 is based on the review of cement, including blended cement, chemical and physical process of hydration, then aggregate, coarse aggregate, natural sand, and crushed sand. So this we have detailed learn in also second year civil engineering, that is in the concrete technology. But in the unit 1 also we will learn in detail what is cement, then what are the physical and chemical properties of cement, heat of hydration, and then natural fine aggregate and coarse aggregate. About this we will learn in this again unit number 1. Okay. Okay. So then this is the unit number 1. So now if we go for the unit number 2, so unit number 2 is based around addition of the concretes or addition to the concretes. So the basic ingredients of concrete are cement, sand, aggregate. But so something we can add in the concrete, that is the review of types of covering, pulverized fuel ash. So you are replacing the ash. Sorry, you are replacing cement by ash. then ground granular blast furnace slag, then silica flume, then rice husk, ash, then manufacturing process, then physical characteristics, then effect on the properties of the concrete. So this much addition to the concretes are there. It means you are replacing cement by some fly ash, some rice husk, or some silica flume, or furnace glass. It means whatever waste is there, so that waste is we are using as ash in the particular for the replacement of the cement. So this is the addition. Or sometimes what we are doing, sometimes we are using the brick bats, म्हणजे विटांचे तुकडे, brick bats, and that brick bats we are hitting म्हणजे भाजणे, भाजतो आपण विटाचे तुकडे, and that we are replacing for the aggregators. It means instead of aggregate we are using brick bats. So whatever heated brick bats we are replacing for the aggregate. We are replacing to the cement by fly ash, rice husk, or any silica flume, other some waste materials we are using. So these are the additions to the concrete. Is with the basic ingredient we are addition of this. It means we are replacing. It means we are not using cement at all. That is not. Some of percentage we are replacing by fly ash. Some of percentage we are replacing rice husk for the cement. Whole cement we cannot replace because the cement is what? Which type of material in the concrete? The binding material. Cement is a binding material in the concrete. So then next point is the admixture. So okay, so the admixtures we have to use in the concrete as additives. So various types of admixtures are available in the market. So the types of admixtures we have to use depends on their requirement. So there are various types of admixtures are there. Some of the admixtures we are using for maintaining the workability of concrete. Some of the admixtures we are using to get the strength of the concrete. Some of the admixtures we are using for the getting early strength of the concrete. So likewise we are using admixtures. So their admixtures are the plasticizer, super plasticizer, retarder, accelerator, and curing compound. So these admixtures, their effects and properties of concrete that we have to study. So this is the unit number 2. Okay. So now unit number 3. So unit number 3 is the properties of fresh concrete. So some of the properties of concrete are there. In that, workability of concrete is there, bleeding and segregation is there. So what is workability? So on which factor the workability is depend? Who will tell? On which factor workability is depend? The workability depends on the water cement ratio. Workability of concrete depends on water cement ratio. How much water you are adding to in the concrete. The flowable concrete is more workable, and less flowable concrete is less workability. So workability is a very important part of the concrete. So that is the properties of the concrete. Then bleeding and segregation. Have you seen many times the the slurries are came in the surface and the aggregates are settled at bottom. If you put the concrete in the column from the some height, at that time what happened? Due to the heavy weight of aggregate, the aggregate will be the at bottom side and slurry will be the at top side. So that is nothing but the segregation. Sometimes slurry will be flow, that is the bleeding. Sometimes slurry will be flow. It means the aggregate will be separated and slurry will be separated. So the that is the bleeding and segregation. Then theory and application principles governing in the concrete placing of compaction and concrete durability. So how to place the concrete and compaction of the concrete. So the placing of concrete is again very important aspect we have to consider while placing the concrete, because if we place the concrete from higher height, so there will be the segregation and bleeding will be there. If we do not compact concrete properly, then also your segregation and bleeding will be there. So honeycombing will be present. So that we have to learn this. Then durability and impermeability. So what is impermeability? So there may be a voids will be the presence if we do not compact properly by the needle. So you have seen the needle vibrator. So various types of vibrator which we are using for compaction of concrete, that you know. Then microstructure and carbonation of concrete, fire resistance. So carbonation of concrete. So concrete will also carbonate. Why? Because concrete and steel, these two main materials which we are using in the concrete, reinforced cement concrete. So steel is there and concrete is there. So the steel will be the first steel will be corroded, and with the contact of the steel, contact of concrete, steel will be there. So the concrete is also carbonated or corroded. So fire resistance. Next point is this here, fire resistance. Is the concrete is fire resistance? Who will give me answer? Is the concrete is fire resistance? Okay, so nobody to answer. Actually, concrete is a fire resistance. Why? Because the concrete having the capacity to resist the fire. So if we consider the steel, steel is not a fire resistance. More than 300, 400 degrees Celsius temperature will be there. The steel will be going to melt. But the concrete is not going to melt, even though 100 and 1100 degrees Celsius temperature will be there. 7,000 degrees Celsius च्या वर जर temperature गेलं, then your concrete will be the resistance to the fire. So this is our third unit. Then unit number 4. So the unit number 4 is a special concrete. As we have discussed, second outcome is special concrete. So the high performance concrete. So the special concrete is having various types of concrete. So high performance concrete, high strength concrete, fiber reinforced concrete, lightweight concrete, high density and radiation shielding concrete, high volume fly ash concrete, self compacting concrete, and a recycling concrete. So these are the various types of concretes which we are using in various locations, depends on the performance. What performance we required? We require early strength. We have to use the concrete in water. We have to construct the structure seawater, under seawater. So if we have to use the prepare the lightweight concrete, we require the high density concrete. So we are replacing steel by the fiber. So these various conditions are there, and that in these conditions we are using the concrete. That various types of concrete we are calling as a special concretes. Are you getting? So these special concretes are various types of concrete, and we are preparing these various types of concrete depends on the requirement or situation. So if we see the high performance, it means what? High performance. So high performance, high strength, we will get early strength of concrete. Fiber reinforced, it means we will replace the fiber to the steel. Then lightweight, so instead of aggregate, we will add the burn brick bats in the concrete for the replacement of the aggregate. So we will reduce the light weight of concrete. Then some hollow balls we will use in the slab. Some hollow parts we will use in the slab, so that we will reduce the weight of concrete. So likewise, so fly ash concretes, we are replacing the cement by some of the percentage by the fly ash. Or recycled concrete, it means whatever waste materials are there that we are processing and we are using in the concrete. So such various types of concretes nowadays we are using for the as a part of sustainability and environmental condition. So this is the unit number 4. We have to learn in detail in the unit number 4. So so we will stop here today.